Okay, so we're going to look at end behavior of polynomials here. So first let's define the end behavior. Of a polynomial describes the far left and far right sides of the graph. For polynomial functions, there are 4 types of end behavior. So let's take a look at what this means. This is a graph of a polynomial. So it's basically, what are you doing on the left? As the graph goes left, so the mathematical way to describe on the left is x approaching negative infinity. Because if I think of, and I isolate the x-axis over here, it goes left and right, and if you go all the way to the left, it's like a number line that has negative infinity on that side and positive infinity on that side. So I'm going to say as x approaches negative infinity. So as x approaches negative infinity. So this is x approaching negative infinity, right? It goes all the way out this way. You want to describe, is the graph pointing up or pointing down on the left side? So this one is clearly pointing up because of this arrow. So as x goes to negative infinity, when we describe up or down, we're going to use y. So if you think of the y-axis, if I just isolate the y-axis, I'll do that over here. The y-axis goes up and down, and at the bottom you have negative infinity, at the top you have positive infinity. So you're going to say y goes to positive infinity because it goes up. Whoops, that's not where I'm putting it. As x goes to negative infinity, y goes to positive infinity, and that means up. So really what it comes down to is the positive or the negative, and then if you're saying x or y. So if it's the x-axis, positive means to the right, negative infinity means to the left, right? So on the x-axis, positive infinity means on the right side, negative infinity means on the left side. If you're going to use the y-axis, positive infinity is up and negative infinity is down. All right, now it says as x approaches infinity, so that's as we move all the way to the right. So let's look on our x-axis. As x goes to positive infinity, right, this is x going to positive infinity. If I look at this arrow, it means the graph is going down, and that's the y-axis that goes down, so y would go to negative infinity. So y would go all the way down to negative infinity. So we would say y goes to negative infinity. That means down. All right, so basically, without this crazy notation, infinities and stuff, it's like on the left side of the graph, it goes up, and on the right side of the graph points down. That's all you're really saying. But you have to use this math language. X, when you have an x, it either means left or right. The x is for left or right, so it's negative or positive, right? The y over here is for up or down. So let's look at this one. As x goes to negative infinity, so this means as you go to the left, x goes to negative infinity is that side. Right, that's x going to negative infinity. Goes all the way negative. Which way is the graph pointing? Well, the graph is pointing down, so y would go to negative infinity because down is negative. So negative infinity, that means down. All right, now as x goes to positive infinity, that would mean on the right side because x going to positive infinity. So this is x going to positive infinity. You go all the way right. What's the arrow doing? Is it pointing up or down? You have to say that it's pointing up. So y is going to positive infinity because up is positive. So y goes to positive infinity, which means up. All right? So you might want to make a little note of that, what these things mean. Up and down, left and right. So let's check out this one. I could just, without the fancy notation, I could just write on the left, the graph points down. We can clearly see that there. And on the right, the graph also points down. We can clearly see that. So the concept isn't difficult. It's like writing it in the math. So first I want to say on the left. How do you say on the left? Well, you got to use x because x goes left and right. So if you want to go left, you got to go negative on the x-axis. So as x goes to negative infinity, that means on the left side, the graph goes, we said down. So y would go to negative, right? Because down is negative. Y, negative means goes down. So that's how we would say points down. Y goes to negative infinity. This is as x goes to positive infinity, so that's on the right side. This is what we said over here. On the right, we could see the graph also points down, right? So if it points down again, that means y must go negative. All right, let's check the end behavior of this. On the left side, it points up, and on the right side, it points down. So as x goes to negative infinity, that's the, I'm sorry, this is pointing up. Points up, and it points up. So on the left side, x goes to negative infinity. The graph goes to the y goes to positive infinity, which means up. Remember, y going to positive means up. As x goes to positive infinity, so this means as you go all the way to the right or on the right side of the graph, y goes up again, which is positive infinity. So notice that left is negative infinity, right is positive infinity. Up is positive infinity, up is positive infinity. So when you have positive infinity, what determines if it goes right or if it goes up? Because both of those things are positive infinity. It's if you have the x or the y. If it's y positive, it goes up. If x is positive, it goes right. Again, just think of your axes. The x-axis goes left and right, so x can only be left or right. The y-axis goes up or down. Whoops, these are arrows. So the y can only be up or down. You can't say y goes whatever to try to mean right or left. All right? Now, there is a way to figure this out from the leading coefficient. And this can get a little tedious. I think this might be better to go over in class together. So we're going to stop the video here.